In this illustration, we'll discuss about a particle grazing the surface of Earth. Here we are given that a particle of mass m is projected in transverse direction at a height h above a point A on Earth's surface. It is asking what should be the value of projection speed so that the particle will graze along the Earth's surface tangentially at the diametrical opposite point B. Here to analyze the situation, let's draw the picture for the motion of this particle which is thrown at a height h above the Earth's surface. So if this particle is thrown with the initial speed v, to reach a diametrically opposite point B, it should be thrown with such a speed that it follows an elliptical trajectory, and finally the minimum distance of trajectory from the center of Earth should be equals to r. Then only we can say it will be able to graze the surface of Earth. Say if this speed is v1, this distance would be r, and at this starting point the distance from center of Earth will be r plus h. So again we can write like several other illustrations we have discussed, in reference of Earth or in the frame of Earth, we conserve energy and angular momentum of particle. Angular momentum will be conserving with respect to the center of Earth. So in the situation here we can write, by conservation of angular momentum, we can write at initial point if it is thrown at a speed v, angular momentum will be mv r plus h, must be equal to at the other point where it is tangentially grazing the surface of Earth at point B, it is mv1 r, which gives us the value of v1, the speed at point B, which is equals to v r plus h by r. And similar to this, by conservation of energy, here we can write initial kinetic energy of body was half mv square, and potential energy due to Earth's gravity is minus gmm by r plus h, is equals to the final kinetic energy at point B is half mv1 square minus gmm by r. Here we can substitute the value of v1 correspondingly. This term can be taken on left hand side, and this gives half mv square multiplied by, this can be written as r plus h by r whole square minus 1, and remaining terms if we take on the other side, you can see by eliminating negative sign we are getting gmm multiplied by 1 by r minus 1 by r plus h. On further simplifying this, here m gets cancelled out and the value of projection speed v can be obtained as the result. You can simplify and obtain the result which I am writing here. This will be 2gmr divided by r plus h multiplied by h plus 2r. This will be the final result of this problem.